And let's try and solve this in the analytical method to actually verify our answer. So this is the first order linear differential equation, and you will notice that if we take y to this side, so it become plus y, and we remove it from this area, it takes on the form dy over dx plus py equals to q. And in this case, p will be equals to what? 1, because the coefficient of y in this case is 1, and q will be equals to 2 1 plus x. Now how to solve this is you first find what we call integrating factor. Integrating factor IF is simply given as e raised by the integral of p dx. In case you don't know how to solve differential equations, I'll link a video where I taught this in the description box. So this is going to be equals to the integral of what? 1 dx, so that's simply e raised by x. Now you multiply through the entire equation with e of x, so that will become e of x dy over dx plus e y exy equals to 2 ex1 plus x. Now you notice that this is actually a differential of the product d over dx y e of x. Just check it, try and differentiate this using the product rule. You find out that it will actually give you this. So it's going to be 2 1 plus x e s by x. Now simply integrate both sides. We're going to have yex on the side equals to 2 will come out, leaving you with, we're going to simply expand this ex plus xex. Now we need to integrate this using integration by parts. Remember, integration by part is u dv is equals to uv minus vd. So in order to integrate this, it's going to be, let u be equals to x, so that means du is going to be equals to dx, and dv is going to be equals to e raised by x dx. If you split this, maybe to look much more understandable, it also has 1 dx. And so therefore in this case v will be equals to e raised by x. If you have to integrate this one is simply to integrate this, you simply write ex then over the differential of this, which is simply 1. So it's simply going to be 2 e of x. Then we are still on this. This is now going to become plus u in this case is x, v is e raised by x, minus integral of v, what is v in this case, ex d u. When this gets to be d, it will actually be dx because we're dealing with x. So this is going to become 2 raised by x plus xex minus, original differentiate this ex. If you open the bracket, this is actually supposed to be 2 times everything here, not just 2 times 2ex. So it's going to be equals to 2. If you open this is subtract this, leaving it only 2xex plus c y e x. And you can divide through with e of x, so it's become y equals to 2 e of x to cancel here plus c e raised by minus x. I just brought it up so it comes negative. Now remember our initial conditions, x naught was equals to 2 and y naught was equals to 5, because we need to get this constant here. So y is going to be equals to, actually y is now 5 equals to 2 times 2 plus c e raised by what? Minus 2. If you solve all of this, you're going to get that c is equals to e raised by 2. So now we have that the equation will be y equals to what? 2x plus c e raised by 2 e raised by minus x. If we simplify, it's going to be 2x plus e raised by 2 minus x, just using exponential algebra. So now we can now find values for when x is equals to 2.2. So when is equals to 2.2, y equals to what? 2 times 2.2 plus e raised by 2 minus 2.2, which equals to what? 5.21873. This gives us like a larger estimate that is actually closer to the actual answer. So I'm just going to put as y analytical. So it's going to be 5.21873. So then for y2, this is y1, it's going to be equals to, that's when x equals 2.4, right? Going to be equals to 2 times 2.4. It's going to give us 5.47032. For y3, x is equals to 2.6. It's going to be equal to 5.74881. It's going to give you 6.04933. And then for the last one, x equals to 3, it's going to give you 6.36788, which is, you can see the answers are very very similar, few discrepancies, but the analytic is much more accurate. So thank you for listening. I hope you understood.